Evolution of trigonometry. Hi, this is Maslea. In this video, I'm going to explain to you the evolution of trigonometry. Trigonometry as a topic started long time ago, the time when kindergarten and primary schools. Because in those period of time, we are taught about different shapes. Shapes like a square, a rectangle, a triangle, just to mention a few. These are the kind of shapes that teachers taught us at that period of time. Now, one of the shapes which I've alluded is a triangle. Let's see how this triangle is going to turn into trigonometry. As we move to grade 8 and 9, the curriculum developer introduced a special type of a triangle called a right-angled triangle. A right-angled triangle, this is a triangle that have a 90 degrees inside it. It's a triangle with a 90 degrees. With the introduction of a right-angled triangle, it gave birth to a topic called Pythagoras theorem. Therefore, Pythagoras theorem, it is the branch of mathematics that deals with the calculation of the sides of a right-angled triangle. Under Pythagoras theorem, we now deals with three sides of a triangle, which are hypotenuse, adjacent, and adjacent. With Pythagoras theorem, we calculate these three sides which I've mentioned. How? By using Pythagoras theorem, which states that the square of the hypotenuse side is equal to the sum of the square of two adjacent sides. Thereafter, let's move to grade 10 to 12, which is the secondary level. Under secondary level, the curriculum developer maintained a right-angled triangle. Now, to differentiate this right-angled triangle from the right-angled triangle under grade 8 and 9, which is Pythagoras theorem, they introduced one thing which distinct it from Pythagoras theorem, which is a theta or an angle. The introduction of an angle in a right-angled triangle gave birth to what we call SOHCAHTOA, where now we discuss about three trig ratios. These are the sine, the cosine, and the tangent. With the introduction of theta inside a right-angled triangle, it also gives rise to a new side of a triangle called opposite. So meaning that as we move to secondary level, Pythagoras theorem has turned into trigonometry by one maintaining the same right-angled triangle, but in this case, there is theta. Therefore, at this stage, we are calculating not only the sides of a right-angled triangle, but also the value of theta using the trig ratios. After appreciating the right-angled triangle and the calculation of the sides and different angles inside a right-angled triangle, the curriculum developer made a step further by interrogating any other type of a triangle. The curriculum developer thought to say, since they now know and appreciate a right-angled triangle, they are able to calculate the sides, they are able to calculate the angles. How about a non-right-angled triangle? Any other triangle? Are they able to calculate the sides and the angles inside any non-right-angled triangle? By non-right-angled triangle, I simply means a triangle without a 90 degrees. So a non-right-angled triangle now gives rise to two rules that we need to appreciate, which is the sine rule and the cosine rule. So as you can see, we have moved from identification of shapes from kindergarten to trigonometry. Now, under sine rule and cosine rule, this is a concept which the examiner interrogates you guys during the final exam mathematics paper 2 under section B. So meaning that you need to be able to identify a situation where you are supposed to use a sine rule and a situation where you are supposed to use a cosine rule. When you appreciate the identification of these two rules, then you also need to know how to find the area of a non-right-angled triangle. After knowing how to find the area of a non-right-angled triangle, you also need to know how to calculate the shortest distance within a non-right-angled triangle. So this is the evolution of trigonometry. As you can see, we have reached at the point where we are discussing trigonometry. Now let's go to the exam. As I said earlier on, the calculation of the sides and angles of a non-right angle triangle gives us two rules, which is the sine rule and the cosine rule, that we need to know and that we need to appreciate. However, the right angle triangle that uses the trig ratios, or commonly known as SOHCAHTOA, that concept is interrogated under mathematics paper 1. So you need to be able to enjoy both a right angle triangle and a non-right angle triangle as far as the calculation of the sides and angles are concerned. This is Maths Layer, and watch the next video where I'll now dig out on sine rule and cosine rule. Thank you for watching this video.
Mr. Matsileya, Mr. Matsileya, oh, Mr. Matsileya, Mr. Matsileya, Mr. Matsileya, Mr. Matsileya, oh, Mr. Matsileya.